This final step now, we want to convert the rate that we got of roughly 10,000 per minute, 10,000 are relative light units per minute, into a concentration. And for that we have done a standard curve where we have taken known concentrations of our GFP protein here in micromolar, and we just simply measured the fluorescent that these different concentrations actually emit in this machine. And we get a nice sort of standard curve. I probably should label this standard curve here. So here we've got the GFP concentration in micromolar, and here we've got the relative light units. And we see it's a nice, almost perfect standard curve, and we have even the equation for the standard curve here. So what we need to do is we need to now figure out, we said we've got roughly 10,000 RFUs per minute. So we need to figure out what concentration this would be. So that would be something between 2 and probably 3 micromolar. But we can, of course, do that a little bit better, because we can write this as y equals mx plus c. So that's the standard form for any straight line, for any trend line here. And we can solve this for x. So we bring the c to the other side, and we have mx equals y minus c. So x equals y minus c divided by m. Luckily, we don't have an intercept here. C is 0, so in this case it would be just simply y over m. And our y, that was the RFUs per minute that we've calculated. So that is 10,000. We said 10,000 divided by the gradient of 3,900. And we can just simply do that in Excel as well. So we would then calculate 10,000 divided by 3,900. That's our gradient. And I probably should add an equal sign in front of it. And that gives us this concentration of GFP. That does not look right. What have we done? We've got a 0 here missing. It's always good to check these things. So we would get a concentration of 2.5. So we've got 2.5 micromolar per minute, and that would be our maximum protein production with the data that we had here in our experiment, in our volume of 10 microliter. And of course, we could, if we were inclined that way, we could also calculate the number of moles that we produce just simply by multiplying this value with the reaction volume, where we had 10 microliter, and we can calculate the number of moles per minute. So that is basically how we can address this question. It's a little bit long-winded, but actually that shows you how we can just simply use tools in Excel to figure out the gradient, how much of the protein we have actually produced in this experiment. So I hope this makes sense, and thank you very much for watching.